So we want to tell you something about the relaunch of the UO-D BW FU series, which is called a brackish water series. We have done a lot of years before, 15 years to be exact, with a motivation that we had reverse osmosis to desalinate brackish water. Not the normal series in Herco. We are used to have a tap water with 1000 ppm or something like that, and a lot of well waters have a lot more than those 1000 ppm in salinity, and we created a system with the brackish water ROs, and now we found a new application, saving water with RO systems with those brackish water systems. So we have some examples for use as second stage for reverse osmosis to recycle a lot of wastewater there. And we present at the end of this day and this webinar a payback calculation program. Here we are in the part 1, relaunch of our BW series, brackish water RO series. You see here on the picture an example of it. And we will go further to explain what's the difference between the old ones and what's the new things in the new one. So the Herco BW series was designed for a TDS of feed water of less than 5000 ppm. Remember, we are in the range of 1000 ppm with our normal tap water and well water reverse osmosis. So we have a permeate recovery, therefore, between 50 and 75%. We are used to have 75 to 80% in our standard reverse osmosis systems. But if we talk about brackish water, we are limited because of high salinities in the concentrate there. So they are suitable for brackish water, well or processed water with high salt concentration, and for reverse osmosis concentrates, which represent also a water which is high in salinity. We have some things already included in this brackish water series and options. So the relaunch will be that we change the controller, the RO1000, very well known for our standard reverse osmosis used since I think 20 or 30 years. We will have afterwards a word for this reverse osmosis controllers we have. We switched to RO digital because all operation values can be monitored and logged. And this is a feature which is always necessary today. We have optional interfaces or even upgrades to PLC controllers in this RO digital world. All units are equipped with variable frequency drive pumps, which have really big advantages in energy saving. So no energy loss if the TDS or temperature is out of the spec. And we have a permeate flow, which is automatically adjusted. It's measured and transmitted, the value of flow of permeate and the variable frequency drive of the motor of the pump regulates then the permeate flow. We have the options of 2 dosing stations which can be connected. So antiscalant is normal for the brackish water systems. Nobody will pre-treat the water of a brackish water system with a softener. We always use antiscalant dosings. And sometimes it's good to have an acid dosing additionally because the precipitation of caustic solutions are very hard to remove.
Right. Okay. Oh yeah, and for those of you wondering about the FU, that's the German name for the variable frequency drive pumps.
Yeah,
so
Bremsumrichter. Yes,
exactly.
So it's a German word. So
it's a bit shorter.
Yeah.
Okay, so this is what the new series looks like. You can see here the table that you will find also in our price lists, the new ones that we will send out by the end of this week or beginning of next week. And you can see that we have also changed a bit which sizes we offer. So we go from a very small size that you know already, the 250, up to the 10,000 liters per hour size. And of course, we can also do larger plants. So larger plants are simply on inquiry, but we will be happy to quote that as well. These were the sizes that are, I think, most often used, and we have a good graduation here. What is also very important, very often we get inquiries also for piloting. So some of you guys do pilot plants, and then you need a small plant to get all the data for piloting. The advantage we have here is the 250 liter per hour was always a good size for a pilot plant. And now with the new, with the RO digital controller, we also can log all the data. So that was not possible before. And the advantage is the pump with a variable frequency drive can really adapt. So no matter if you operate the unit with, let's say, 5,000 milligrams per liter TDS or 2,000 or 1,000, or whether you use a membrane that needs higher pressure.
Exactly, or higher temperature, lower temperature. So it's very, very flexible. So
exactly.
Also the different membranes that could be tested are very important for piloting. So we have high rejection membranes or even nanofiltration membranes,
would still work.
Low fouling. So there are different of applications. If you pilot something, you want to know what is the effect of your raw water with a brackish water system or with a reverse osmosis desalination process, and you can make then real process studies about it.
Exactly. And you see here the small unit. So you see it's pretty compact. You can put it anywhere. You can see also on the view of the left-hand side that you have the dosing units already, or there's a place already for the dosing pumps, so they can be easily mounted. And it's perfect for use with, let's say, I don't know, a small tank or something as a pilot plant. Okay.
So the previous controller is my topic because I'm the older one.
Yeah,
so
exactly.
The old controller is for
right?
me. Yes, it's my life more or less. No, previous controller, the RO1000 controller is very well known in the world because we have a lot of installations in worldwide, more or less, with this RO1000 controller. Loved by a lot of people and hated by them who know that a new controller is on the list here because the features of the new is breaking down the old one. So the RO1000 is in use since the mid-90s for single stage RO units. 2009 was the successor, the RO Digital launched. We have two-line display, navigation via keys. We have a display of operating status via LEDs. It's the disadvantage, no monitoring of flow and pressure or current is possible. So no data logging even, because if we have no data on the data logger, we have no connection to central control systems. And I think this is a disadvantage which breaks the neck of this RO1000.
Exactly. That's why we decided to take it out in the end.
Yes.
Even though people were sad, we have to admit. But I always think it's same like when you get a new version of Excel, let's say, or Word possibly.
Yes.
Like everybody hates it, and then after 2 years, you cannot work with the old one anymore.
The better is the enemy of the good one.
That's true.
That's it.
So we go for the better.
Yes.
That's the RO Digital. You probably all know that. So now we use that for most of our RO series. And with the price list that we send out this year, we have taken out all the RO 5000 and 1000 units, really. We have a 4-line display with a code, with a name as well. Navigation via keys, that's not so different. And also we have LEDs there still. But we can now monitor all the flow and pressure values. We can log the data. And we can connect to a central control system via several interfaces that are available optionally. So you have a lot more options to monitor. You can get alarm values also. That was not possible before. So it's a big advantage, really.
Yeah, the interfaces and PLC options. I think it's in the modern world, it's necessary to be available, to be able to transmit the data to external devices. And this, the RO digital controller can supply. It could be combined even with a variety of interfaces. So the available options are Profinet, which we are very often have in use because the industrial world is covered with these Profinet bus systems. We have Profibus, we have the option of Modbus RTU and Modbus TCP, and even BACnet, which is also a network which is used in a lot of cooling tower installations,
buildings, right?
Yes, exactly. So we have a scope of delivery that includes hardware as well as engineering costs. So the transfer of 30 data points are included normally in our standard program processes. And I think if you think about what has to be transmitted, the main ideas are the flows, the pressures, and the quality of the produced water. Yeah. And I think 30 data points are a lot of things which could be transmitted.
Yeah, you can also transmit alarm signals, for example, general alarm or also certain alarms if you need that.
Yeah. So I think it's very important for big installations where everything has to be visualized in a central control room, like in data centers or where the projects we are doing with our clients, together with our clients, are positioned and located. So at the end, we can also use this step of transmitters and transmitting informations to also upgrade the our digital controlled systems with a PLC device. So
exactly.
I think this is then the next step in compatibility to external devices.
Exactly. And you can find that also in the price list. It's the same option as for the anti-scalant series. So pretty similar. Good. The variable frequency drive. So our units have always been available usually in two options, with variable frequency drive, without. This is the first series that we are now offering as a standard with a variable frequency drive. There are very good reasons for this. With a variable frequency drive, instead of a throttling valve, you can adjust the system, and you see this graph here. You don't have to move on the pump curve and maybe go to a point where you use actually more energy and where you really, let's say if you need less pressure than what your pump can give you, you destroy the energy with a throttling valve, but you basically move from one red point to the other here, and you go as if you would go to a smaller pump, right? Because you can adjust the frequency. So the advantage is you have a lot less energy consumption. The noise emissions are also reduced, right? I think you told me that you can really hear the difference when you stand next to the unit.
It's a very smooth operation there. And smooth operation means also very, very smooth in case of
wear and tear of the
loudness.
Parts,
yeah, exactly.
Right? It's easier on the parts of the plant as well. You have no big variations in pressure or something like that. And there's also an advantage. You can use the same pump in the 50 or 60 hertz electrical grid. Okay. Just one very, very small disclaimer here. If you order with the KVP, so with the flushing device, if you have very critical water, that pump is only for 50 hertz. So there you have to go for 50 hertz, but we're working there also on a 50-60 hertz version.
Okay.
Probably for next year. Okay, pumps with integrated VFD, that's the variable frequency drive that's directly on the pump. You know that from our systems are very easy to install. You don't have to install the variable frequency drive in the switchboard, but it's just on the pump. And the drive is matched directly to the pump because it comes from the pump supplier. We have a few examples here for you for this energy consumption reduction. As René wrote in the chat, we have done a webinar, maybe you remember, on just energy consumption.
Yes.
So we have some very interesting points there as well, more details. you can see that you have, if the TDS, for example, changes, you have 2,500 milligrams per liter instead of 5,000, and this can easily happen. We'll show you that later. You can get at least a reduction of 20% or more. If you have a temperature of 20 degrees instead of 15, which is our design point, you can also have a reduction of about 15%. I think it's, you said 3% per degree Celsius,
yeah, exactly,
right?
yes, exactly. It's 5 degrees and 3% per degree. Then we have 15% less pressure need if you have a higher temperature than our layout design temperature. And so we are really flexible with this variable frequency drive on our motors, because it's always playing with the system. So it's never the designed circumstances is always a bit different. And the difference means that we have a very strong pump, which makes really the critical points, but the points are not often very critical. So we can move down with the pump frequency and so save a lot of energy.
Exactly. And you know, the energy prices right now are really not going down, quite the opposite.
No.
So we don't see in the near or even in the midterm future any change in that. And that's why we are trying to really move a lot more in the direction of variable frequency drive, because you recover the small additional cost for the variable frequency drive within the first few months of operation.
Yeah. So the combination of all those effects could lead to 30% up to 65% of saving energy in a reverse osmosis system. And you will see later what are the real factors in costs of an operation of a reverse osmosis. And even in our discussion, water will be a very, very dominant. Energy is also one of the factors which cost money in operation of reverse osmosis.
Exactly.
Okay, all the changes we did in the BW series we have launched is the instrumentations. We already have the explanation about that. We have the sensors instead of rotometers in flow measurement. We have pressure analog sensors instead of manometers. We have elimination of control air, even in large units. So the use of electric automatic valves is here now standard, because a lot of environments in these applications of data centers and clean regions in a factory, they don't even have pressurized air as control medium. So we have switched over to automatic valves using electrical motors. So we have options. Polypropylene pipe work is available as an option. We have the PLC controller as an option, as an upgrade option. And we have with that the interfaces for external devices.
Exactly. So quite a lot of changes.
We started with the brackish water systems to desalinate brackish water, but now we are in a very, very interesting application in saving water with the RO systems, and you will see what we have to say about it.
Okay, so this is where we wanted to present you also our new vision that we have chosen here at Herco, because one thing is, of course, we see the demand, but we also think it's important for us to look for sustainability, because we don't want to build plants that are maybe, I don't know, cost, let's say, relatively cheap, but then they will waste a lot of water. I mean, it's not the time of that. For that, we see that water needs to be conserved, and we want to contribute to resource efficiency, to water saving, to energy saving with technology, with water technology, which is what we are proud of, what we care about. And that fits very well with what's going on politically, let's say.
So I'm not a politician, but I think what we have heard about is that we have in the United Nations General Assembly, they concluded to have 70 goals in sustainable development. And one of the main and for us important goals is the clean water and sanitation. So everybody should have access to clean water and sanitation in the world. So I think this is a big word, but we can do our part to have as water saving as possible, as much as possible with our systems we are producing.
Exactly.
And that's also one of the topics of today.
Yeah, and I think it's also a topic we've heard that from some of our colleagues, from people who are listening now, that in some regions where we would never have expected to have water stress, like Belgium, we actually do have a lot of problems with water availability. Right? So this means one thing is the environmental aspect. The other aspect is, of course, if something is more scarce, you will have higher cost. So what you can see is in global water tariffs that there is quite a big increase also. One of the drivers is climate change, really. So systems, water supply systems need to be changed because of climate change. Think about protection against extreme weather. Think about water scarcity in places where you used not to have water scarcity. So this means water costs will go up. So it's also important for your clients to think about what the operation cost of the system will be in 2 years, in 5 years, in 10 years. So it's an important thing environmentally, but also in a very, let's say, hard fact basis for money.
We are in between an ecological discussion and an economical discussion. And I think this fits very, very well. And the driving motor of an invest is not so often an ecological driving force. It's more an economical process.
Exactly.
And
but
the economical process fits into this line.
Yeah, but if both go together, that's a good thing.
It's a win-win,
Exactly.
So we have calculated some life cycle cost, and you will have afterwards also the view in the program we made for you. And the life cycle cost of the RO is very tremendous, driven by water costs. So we have an example standard RO unit with a permeate production of 10 cubics per hour, 75% recovery or yield. Invest cost is like the list price of the unit. We have positioned that. The operation of an RO is, in this case, 12 hours a day and 350 days a year. We operate the system with city water, which water costs are together with the wastewater costs here in Germany, around €5 per cubic meter. It's different in every country, but it's €2.50 per cubic meter each, water and wastewater.
Exactly.
So electricity cost, we thought to take the 0.15 euros per kilowatt hour. So me in my home, I pay more, but
actually,
the industry pays maybe a bit less. But I think it's only a playground where you can put in figures, and you calculate this system over a period of 10 years, which is nothing for a lifetime of reverse osmosis units. And the conclusion is this pie diagram or cake diagram, and you have the cake piece in blue is the water cost, and the cake piece in yellow is the wastewater cost. And you see immediately that it's really dominated by these water costs.
Exactly. So even if you have, let's say, a well water system, we have done that in another webinar, I think in the energy efficiency, with a cost of maybe, let's say, 0.5 euros per cubic meter. Even then, it's a pretty dominant cost, the largest part still. So it's still 3/4 probably. Now it's, I don't know, like 90% most probably. So you see that every little increase in efficiency will really translate in a big saving over the lifetime of the plant.
Okay, some words about water recovery. So we are used to have systems in Herco for higher water recovery. So water recovery starts with a good installation of a reverse osmosis. Our standard reverse osmosis used in tap water applications has a recovery of 75 up to 80%, dependent on the raw water. The advantages of the reverse osmosis without any recovery system is that they are robust, easy to operate. The water analysis is normally not critical. So if it's not really a site where you have a high silica content or something like in South America or so. We have these customized multiple stage RO systems. We call it KR systems, so concentrate recycling system. And they go in typically ranges of 85 to 95% recovery. And you see the picture beneath it. So the standard system with 40 cubics per hour and 75% recovery makes permeate of 30 cubics per hour and a concentrate of 10 cubics per hour. That's the standard operation of a reverse osmosis. If you want to increase the recovery of those systems, you can add a concentrate stage. So you use the concentrate, these 10 cubics per hour, and move it through a concentrate stage, another reverse osmosis, and press out 50% of the permeate out of these concentrates, and you have a 5 cubic per hour saving in using the permeate of the second stage up front to the feed of the first stage. So we have a strong reduction of water cost there in these KR systems. We have really this resource protection, and the goals of the United Nations are very well matched there. The disadvantage is that water analysis is imperative, because you have to use a very good water analysis and a good view of it, because we go in 90 or 95% recovery into concentrations of 10 times up to 20 times the concentration of the raw water. And there you have to know exactly what you are doing, because you have then the possibility that the system blocks, falls out, and you have a lot of problems to overcome. And that's why you have to look at the raw water and recoveries if it's possible.
Yeah, if you can imagine with silica, for those of you who have done the reverse osmosis webinar, let's say you have usually 10 to 20 milligrams per liter easily in the feed water. Let's say you have a system like the one above, you will increase the concentration fourfold.
Yes.
Right?
Yeah.
So there 40, you go,
50,
40, let's say in the worst
80.
case, 80.
Yeah.
In the other case, if you go to, let's say 90%, we're not even talking about 95, right? 90%. So tenfold increase, you go to 100 to 200. And from 100 on, I think you already have a lot of scaling.
Yeah.
So you can see it's a big difference really in the concentrations that you see in the concentrate. So that's the question. There's the option to go for a not so efficient system, but very reliable, because you see you don't have super high concentrations of parameters in the concentrate, or you can go for a system that is complicated, not easy to operate, but that saves water. But you can also combine the requirements. And the idea that we want to propose and that we're going to show you here is the retrofitting of a second unit. So you have two separate systems. We show that here.
So you have big advantages in a second stage RO. The invest is that you have no need to install a completely new RO system. If you have a running RO, then you don't have to break it down and use a KR staged RO system. You only revamp the existing one. So it's no need to shut down of production during installation. You have concentrate from several RO systems and can be traded in one second stage RO. So you will see it afterwards in some applications we done. So the operational reliability is also a very important point. So the second stage completely independent. So you have an existing running RO system with 40, 50, 60 cubics per hour permeate flow, and all concentrates which come normally to the drain, you can collect and recycle it partly through a BW system. And it's very independent, so you will not jeopardy with the performance of your existing production line, and you only use a completely independent RO system for saving water and thus saving water. So you can increase the yield or the recovery of a standard RO system, which works maybe at 75% recovery. You can increase this recovery only by using an independent BW system to 90, sometimes to more than 90%.
Right, and actually the good thing is you can play around with a BW system,
exactly.
Right? Because it doesn't affect your production, doesn't affect your first RO stage.
Yes.
So you can see how much water you can squeeze out. And even if the system, even if you realize, oh, this was too much recovery, you don't have a problem with the first system.
Yeah, you can clean it if it blocks because you are too aggressive in going for higher recoveries in your BW system. But then clean it and then start from new at a lower point of recovery and look what is possible, and go to the barrier, go to the really hot points of recovery that you will never do if it's coupled directly to your production system, because the production doesn't want to be influenced by your playing around here. So it's very, very good to have an independent second stage.
Exactly. And with our brackish water unit, you have a lot of flexibility, and it's really simple to install it. We'll have a look at the values here. So just to give you an idea of the sizes. So our brackish water system is designed for 5,000 milligrams per liter TDS. Now, if you remember our normal systems, they're designed for 1,000 milligrams per liter. So if you had a first stage RO that is existing, that has an input of 1,000 milligrams per liter and has, for a standard RO, high recovery of 80%, you will have a 5-fold increase and you reach 5,000 milligrams per liter TDS in the effluent. So you could still treat that. In a lot of cases, you're actually lower because your drinking water probably has 500 milligrams per liter. Let's say 4 to 5-fold increase, you're at 2,000, 2,500 milligrams per liter. And then you can probably ramp up the recovery of the brackish water unit.
There the game is open. So you never have in reverse osmosis concentrates more than 5,000 ppm. So it's a lot less normally. So here in Freiberg, just for an example, we have around 300 ppm in our raw water. We have, if we are operating an RO with 80%, then we have maybe not really 2,000, less than 2,000 ppm. And so we can operate the brackish water concentrate recycling system 65, nearly 70% recovery. And the overall recovery will be very, very high.
Exactly. So you need to think about what recovery you can choose for the brackish water unit in terms of what water quality do you get at the input, right? Yeah. So if you look at the hydraulics, our brackish water series has a capacity between 0.25 cubic meters per hour, the 250 liters per hour unit, up to 10 cubic meters per hour. That corresponds to a permeate capacity of the first stage of actually 4 to 80 cubic meters per hour, if you consider 75% recovery. Because you think about, let's say you have the 80 cubic meter per hour system. That means you have 20 cubic meters concentrate. And the 20 cubic meters concentrate, you send it to a brackish water unit. You have a 50% recovery in this case. You get 10 cubic meter permeate out, and that's the capacity of your brackish water unit, and you send 10 cubic meters to the drain.
Instead of 20. So it's a big saving. So you will see afterwards if we put numbers on it. So if we put money on it.
Right.
So really good invest.
Exactly. So you see already you can cover quite a high flow rate in your first stage with this series up to 10 cubic meters per hour. And of course, if it's necessary, we can offer larger systems as well. I think we're actually quoting larger systems as well at the moment.
Size is not the problem in Herco.
Exactly. Okay, so the permeate quality of your brackish water unit is the same or better, usually better than the feed of the first stage RO.
Yeah, it's also very important because we want to refeed the permeate of the concentrate recycling stage to the front end of the existing reverse osmosis.
Exactly. So you send that back, and in total, the water saving, your recovery in the brackish water unit corresponds to your overall reduction of the concentrate. You have with the energy consumption also, you have some savings because we equip the units with a variable frequency drive pumps. You have typically 30% less energy consumption, and in the second stage, you have easily 50% because there's the difference in total dissolved solids that can get quite large. There's the difference in temperature, possibly. It's probable that it's warmer actually after passing the first stage. And because we have such a wide range of operating conditions for this unit, we decided that it makes really sense to equip them with a variable frequency drive pumps. We'll go now for the examples and then for the calculation. And I think we'll have to hurry up a bit. But we'll be fast with the examples, I think, right?
Okay, yes.
That's your baby.
Okay, my baby, yes. Case one, it's a wafer fab, which where we install together with clients of company which is directly linked to via the sister companies in the Water group in UK, and it's a semiconductor industry. So it's a wafer fab where they have these more than one reverse osmosis systems. I don't know exactly, but it's 4 or 5 reverse osmosis systems which feed the concentrate into a separate tank, and from there these concentrates are collected and are going through a brackish water RO, and a lot of wastewater is saved there. So what we have installed there in 2013 or 2014 was a second stage RO with a capacity permeate flow of 20 cubics per hour. You see, it's one of the systems which is bigger than our biggest system in the portfolio, a standard portfolio, but it's a size which we are a lot of things used to. They operated the system with 65% recovery because the wastewater which comes there is not so high in concentration. It's not critical. And if you see 2013-14, it's 8 years ago where it was installed, and I think they made a lot of experience in this system and no problem to operate it with 65% recovery. So the operation time since commissioning was now 25,000 hours, water price and wastewater price of €2 per cubic meter. This translates to cost savings of approximately 2 million in 8 years.
If you compare that to the invest of the unit, it's quite good, right?
We are too cheap, I think, in offering those ROs. So it will, later on, it will be
we'll see the calculation.
Even more critical for us. We are too cheap, I think. We are too cheap. But this will change, I promise you.
Somebody's laughing, yeah.
But we have here an example with a break even less than 6 months.
Exactly.
And this is a word, I think.
And this is a very typical value, right? Good, but we'll show you the calculation actually for a let's say, similar case. But we have also another example. That was also your project, right?
Yeah, it was also a baby of mine. And Nicolas, I think he's always visiting this webinar. And he can remember we sold the system to an oil refinery in Angola. Not we directly, but the client of ours had this contact to Angola. And we sold the complete water treatment there. And the solution of the question of request of the clients was an installation of 2 UP units. UP means ultra pure units, combination of reverse osmosis and electrodeionization, with a diluate production of 34 cubics per hour each, so 2 times 34 cubic meter per hour in duty and standby mode. So the concentrates of these RO and EDIs were being collected and partly recycled with a second stage RO. In this concept we made for the clients, this was one important factor, not because the water is very expensive there, it's the availability of water in this region. Africa is normally known as very scarcity water, and there we will not be allowed to work without any energy or water recovery. And this was a possibility there to implement the project with as less as possible consumption of water.
The payback calculation, that's the most important part in the end when you want to sell the unit. We have here the calculation tool, so we want to show you how that is used, and we'll send it afterwards with a handout as an Excel sheet. It's an open sheet, so you can also put your logo instead of the Herco logo. We have discussed that. You have a lot of options here to change stuff and to put in your own pricing, whatever. We want just to walk you through this a bit and show you how it works, and then you can adapt it to your needs. So basically we have an input section, that's the project data. We have scenario 1, that is one existing RO unit, and scenario 2, that's an existing RO unit plus a second stage, and that's a brackish water unit. You can put in the project data, so all the blue cells are input cells, and you can put in the permeate production or the capacity of your existing unit, the yield that you have right now, the recovery, and then you can put in the corresponding brackish water unit. You will see that the system shows you what the concentrate flow of your unit is. Of course, the concentrate flow of the existing RO should be the feed water of the brackish water RO. So in this case, that works very well. You have a bit more than 13 cubic meters per hour concentrate from the existing RO, and you have 13 cubic meter in your brackish water unit. You can play around with this, just take care that the 2 numbers match. Of course, you can go lower. You don't need to recycle everything. If you want to reuse less, no problem. And you can play around with the capacity of the brackish water unit and with the recovery. Just keep in mind, you know the TDS values, so we haven't put that in here because it's not a hard fact. But if you have a TDS that's at the lower range, you can ramp up your yield. So let's say TDS of 2,500 milligrams per liter, probably you can go
up to 65%.
60, 65. If you have a TDS of 5,000, you should better stay at first with a 50%.
Exactly.
Right? When you choose the capacity, that's a drop-down menu that is linked to our second chapter here, the data for the brackish water series. So you can put in directly a unit designation from there, but you can also override that and write your own. Then you will get some mistakes at some point where you have to write new values. If you want to have a larger plan from us, you can also calculate it here, right? So you can put in the running time. We have also kept this open. The operation time of the existing RO and of the brackish water unit doesn't have to be the same. Normally it would be, typically, let's say. But if you want to make, let's say your normal unit works only 4 hours per day, let's imagine, and you say, hey, I want a smaller brackish water unit. So I'm going to space out the working on the flow of the 4 hours over 24 hours.
Yeah, exactly.
Possible,
or
right?
The average value then to have then a smaller reverse osmosis for the recycling.
Exactly.
Yeah.
So it's
but
possible.
You need a big tank then to cover and to collect all the concentrates of the reverse osmosis, which only works 4 hours a day.
Exactly. Yeah. So you need a brake tank anyway, because you want to have no direct connection between the units. And if you take flows from several units, you also need a brake tank to mix. But in this case, if you change the operation time and you have a longer operation time for the brackish water unit, you'll need a larger brake tank. But of course, you can also compare different options here. So you can make a calculation with a smaller unit and a larger break tank and put that in the invest cost and then see what's the most advantageous solution for you. Okay, so what else do you put in? You can put in the water cost, water, wastewater, and the electricity cost. This you take in only for the existing RO because your brackish water unit will have the same costs, obviously. Then the invest cost for existing RO, it is 0 because it's there already. But if you want to look at a case where you have an additional, let's say, you need to revamp something, you need additional stuff anyway, you could also put values there. So it's free. It's just in the normal calculation, it's not required. Then you have the invest cost for the brackish water unit. The system takes that directly from the list price. You can see that here, that it comes from the list price. That means we considered that you have the price with our, let's say, this discount, and then you need probably to do some additional stuff. So list price is probably a good estimate in the beginning. If you know already that you need additional equipment, you need other
tanks
things.
and piping, pipework, workload, and plus, then you can put it directly into the cell.
So you can override it. At the moment, it's the link, so it's comfortable for you. It will take the list price directly. But if you want to override it, feel free. Then we have, so that's all the data you have to put in. Oh, I forgot one thing, the connected load of your unit. The connected load of the brackish water unit comes here directly from the data in the gray section. The connected load of your existing RO, you have to put that in. If you don't put it in, it's not going to calculate the electricity costs for the existing RO, but it will also not calculate it in the second case. So then you just don't have this cost. It won't be a problem, okay? But if you want the entire electricity consumption, you should put it in. Now, how is it calculated? So now we calculate for scenario 1 and scenario 2. You see already here the hydraulic calculation at the bottom. We will calculate the operation cost for both, taking into account the water and the wastewater and the energy cost, and also maintenance. Maintenance we take into account only for our second stage because we assume that you have the existing RO no matter what in scenario 1, scenario 2. So that maintenance is just the same in both cases.
Just the additional cost.
Exactly. We have assumed this maintenance is 5% yearly cost of the invest, which is, I think, quite a good value, conservative, moderate. But also if you have experience there and you assume something else, feel free to change it. As an output, you get a break-even point, you get the total life cycle cost. We'll come to that in the next slide. That's why I want to explain it rather on the next one. And you get also a pie chart to compare the life cycle cost without the brackish water unit. Now we'll show you on the next slide how that looks. So this is the second page of your calculation. You can also print that out really and send it, for example, to the client together with the quote. Yeah, that's could be a very good argument. So you see here you have a cost calculation where you calculate the yearly water cost for both cases. Okay, water cost, wastewater cost, energy, and maintenance cost of the second stage. Then you have number 5, the amortization, where we look at the first 2 years, 24 months, and you can see how the cost goes up. And we mark the point where the scenario 2 with the brackish water unit has a lower cost than scenario 1. And from then on, it's green. So you can see directly when is your amortization of your investment. And you can show that to the client. I think it's a very good argument.
Yes. Even if it's only 3 months here in this calculation.
Very fast, really.
It's very, very good,
But even if you have more investments, you need an additional tank, this or that, maybe you have, let's say, 2 more months, whatever, but you're
not really critical.
So that's why we only put 2 years here, because you're going to be in those 2 years for sure. Really. And we have also the life cycle cost, so you can compare what is the total cost difference in the entire lifetime of the plant. You can put the lifetime in, you see the 10 years here. Of course, usually it would have more. I just chose 10 because it's a round number, but you can put in 15 or 20 or whatever. And you see the life cycle cost and the difference.
Don't use the ROs too long, because we want to
Also
sell a new one. So
yeah, but we have replaced a lot of 20-year-old units lately. So
exactly,
yeah,
yes, unfortunately.
That's problem, right?
Okay.
Okay, but we wanted to show you this example here. I'll just go back. So this is 40 cubic meters per hour, right, for the first system?
Yes.
And then we have a 6,500 brackish water system.
Which fits together in the sizes.
Exactly. And we have typical operation times, 12 hours, 250 days, typical prices. And you can see here that in this case, you have a break-even point after 3 months. Imagine 3 months, it's nothing. But we have also calculated that, and when we send you the tool, you can try it out with a lower water price.
Yes.
And that's where we come to the answer to our previous question.
Wow.
Right?
Yeah. Even with wastewater price, each approximately 0.75 euros per cubic meter, which makes 1.5 euros per cubic meter in total break even after less than 1 year. So
exactly.
Wow.
So you can see that, you can try it out. You can try with a system that you know or project that you have, and you will see that it is quite impressive, really, how fast the payback of the system is.
Yeah.
We'll show you also the pie chart. Yeah. So this is also the result you get from the tool. You can have you see the pie chart as well. And you can, for example, print this out also for the client. Have a look. This is the same example.
Yeah, you see immediately what is the driving force. The driving force of doing something is the water cost. So the blue are the water costs, fresh water, and the yellow cake pieces are the wastewater costs. And if you don't do anything in recycling, in additional recycling technology, then even the wastewater part is really also dominant. 1.4 million euros each. 10
over 10 years.
Over 10
it's
years.
Quite a lot of money.
And if you do something with a BW system in saving water, then you have we go down by 18% in costs. 18%. And I think the cost of a BW system with 6,500 liters per hour costs maybe 35,000 euros, and you have a tremendous saving over 10 years. Tremendous.
Exactly. And here you increase that. You can see also, I just go back quickly. Do you see at the bottom of the page the entire system yield? So you increase from 75 to 85%. Okay, and that results in these savings in total. 18% less, and that's from 5.9 to 7.2 million difference over 10 years. Quite a lot, huh?
Really.
You can even increase this more or decrease wastewater more if you choose. This is our second example. Yeah. Here we have an RO with 30 cubic meters, and you go to the same size of brackish water unit at 65% recovery instead of 50. So you ramp up your total yield of the system from 75 to 90%.
Yes, 90%. And I think this is tremendous what happens there, because there you can play with the brackish water system yield or recovery. And if you go to 65%, which is absolutely normal in concentrate recycling systems of a reverse osmosis of an existing one, it's absolutely no problem to work like that. And you have 24% life cycle cost reduction.
Yeah.
And I think this is not only a small argument.
Yeah, so I think this is really, it's good because you can show the numbers to the client, because if you just say, 75 to 85%, doesn't seem like much, right?
Doesn't say something to the client, but
exactly.
Euros are the really important factors.
Yeah. So you can feel free to play around with this, take the Excel sheet to the client, show him how it works. So no problem. What we want you to take away from this webinar, really, and we come now to the end. We just overdrew 2 minutes, not too bad.
Oh, yes. Okay.
It's always bad if you're so interested in the topic, right? Yeah. So the point is, in the end, you can reduce your wastewater production so much, 50 to 75% less, it's always a good choice if the wastewater, the water and wastewater costs are high, let's say more than 2 euros per cubic meter each. But even for the lower ones, you see that there is always a really, really quick payback.
Yeah.
So it makes a lot of sense. Oh, we have an information. Okay, water wastewater is 2.11 euros in this country.
Yeah.
Okay, 2.11 in total or for each? But even if you have in total, that means it's 1 euro per stream.
Yeah.
You still have
less
a
than
payback
a
probably
year.
of
Less than a year,
so
always.
It still makes sense,
yes.
right? And the higher it gets, the quicker the payback period is.
Yeah.
And the other thing is, you don't impair reliability. You don't need to replace your existing equipment, and it's really a way to future-proof production. So that's an argument for your end client. He has to prepare for, let's say, more water scarcity, higher prices, and it does make sense to invest now in something that will help to secure production in 5 years or 10 years time. Okay, and there we are back. With the well water, good point. Question from one participant: what is the argument when using well water? It's preserving the water, yes. It depends a bit on the country, because in some countries you have a permit to extract well water that does cost you actually, so it does have a cost. In other cases, you have a cost for the treatment of the well water.
Yeah, exactly.
And a big argument is when the well water permit is limited and you cannot get a higher permit, and that is very often the case. I know that for large companies like Coca-Cola or so.
Yes, you are limited. You are limited in your production about that.
Exactly, you can increase it, but you want to ramp up production. And there you have a problem. So if you can increase your water efficiency and ramp up production by 20% without increasing your water consumption, that is a big payback. So that can be even a stronger case actually for the unit when you have no permit to extract more water, even if the water is relatively cheap.
Because a lot of different arguments in different countries and different applications. So. Exactly.
So there are, in any case, there are always arguments for this. We think there are so many options, so many applications where you can use this.
Yes.
And we hope that the tool that we're going to send to you is going to help you to use these arguments and to show the client really what the advantages of the series are.
That's the thing what we give to you. So we stole your time a bit more than the estimated one, but you get something for it, and you get this handout of the webinar, and you get the ROI calculation from us, and you will be ready then to play with the system and to talk to your client about that.
Exactly.
Because it's a very clever idea, and why not use it?
Exactly.